Today we're learning about normal distribution. So normal and skewed distributions are continuous probability distributions represented by a curve. So here's three different curves that I demonstrated for you. We have the first one. This curve is negatively skewed, meaning the mode is located here, and then both the median and the mean are to the left side. So the curve is, we call it negatively skewed. The normal curve is when the mean, median, and mode fall directly in the center of the curve. So it's kind of, you could say, at the peak of this curve. And then positively skewed is when the mode is located here and the median and the mean fall after that or higher than that, which is called positively skewed. We are going to be working specifically with the normal curve. And the normal curve is the same for all the problems. So once we go over the general aspects of the normal curve, you can take those aspects and you can apply them to every problem. So here's what the normal curve looks like. The normal curve has different categories with different percentages, and we'll talk about those in just a moment. But first I want to talk about what standard deviation is. So standard deviation is the measure of spread, or how spread out the numbers are. Once we go through the examples, you'll understand what this is talking about a little bit more. And to represent standard deviation, we use this symbol. So it looks like it's, I guess you could say an O or a circle with a little tail on the top. It's called sigma. It's a Greek representation of that symbol, and it represents standard deviation. So once again, when we go through the next few examples, you'll see how this is going to apply to the normal curve. Right now, we're just talking about the key aspects of it. So the normal curve has its mean, median, and mode all located directly in the center. From here, we're going to spread out. So we're going to look at these two columns of your normal curve. Now, every time you work with the normal curve, these two columns represent 34% of your data. Every time, 34%. So 34 plus 34 is 68. And that's where you get 68% of data falls within one standard deviation. So it falls within one column to the left and right of the mean. Next, we're going to look at the two columns out from the mean, or two columns out from that center. And here we're looking at these two columns, which represent, each of them represent 13.5% of the data. So 13.5 plus 34 plus 34 plus 13.5 is going to give you 95% of the data is within two standard deviations of the mean. After that, we're going to take a look at the next column on each side, which represents 2.35% of the data. So if we have 2.35% plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, this is representing 99.7% of the data. And that's saying 99.7% of the data is within three standard deviations of the mean. So just to go back through this, if the mean is located right here in the center, one standard deviation on each side, so plus 1 on each side, that's within one standard deviation. 2 lines is going to represent 2 standard deviations away from the mean. 3 lines is 3 standard deviations. You can see these marks right at the bottom here. And then anything after that represents 0.15% of the data. So 0.15% of the data is beyond our 3 standard deviations. So, of course, I just explained where your 68, 95, and 99.7 comes from, but written right here, I just wrote out the words for it. So 68% of data will fall within one standard deviation of the mean. 95% of data will fall within 2 standard deviations of the mean, and 99.7% of data will fall within 3 standard deviations of the mean. And then anything after that, it's a very small amount, it's 0.15%, and that's beyond 3 deviations. Okay, let's take a look at our first example so we can apply what I was just talking about in case you're just sitting there thinking I have no idea. So this problem right here talks about the heights of basketball players. So the heights of players in a basketball league are normally distributed with a mean of 6 feet 1 inch and a standard deviation of 2 inches. So the important information in here is that it says the mean data is 6 feet 1 inch. And then it also tells you that the standard deviation is 2 inches. So right here, the mean always falls in the middle. In this case, the mean is 6 feet 1 inch. The standard deviation is 2 inches. That means add 2 inches here. This becomes 6 feet 3 inches. Subtract 2 inches. That becomes 5 feet 11 inches. So both of these numbers, 5'11" and 6'3", are 1 standard deviation away from the mean. We just subtracted and added 2. That's 1 standard deviation. We're going to do that again. Add another 2 inches gives us a height of 6'5" inches. Subtract 2 more inches, we get 5 feet 9 inches. So this is within 2 standard deviations of the mean. Okay, we added 2, we subtracted 2 again. Let's do this one more time. Add 2 to 6'5", we get 6'7" inches. Subtract 2 from 5'9", we get 5'7" inches. So every time, starting at the mean, for every deviation, we add 2 inches, moving to the right of our curve. Moving to the left of the curve, we're subtracting 2 inches every time. So now that we filled in our information, we filled in our mean and we filled in what our standard deviation is talking about, we need to take these percentages that we just talked about. So these percentages never change. They are the same for every single problem. So in the first 2 columns, these 2 columns represent 34% of the data on each side. So within 1 standard deviation, we're talking about 34% of the data. Within 2 standard deviations, we're talking about 13.5% of data. Within 3 standard deviations, we're talking about 2.35% of data. And then we are talking about 0.15% leftover data after our 3 standard deviations. So these numbers never change. You fill in the information specific to your problem, and you use your percentages on the normal curve. So now we are going to use this normal curve to answer all of the questions. Part A says, what is the probability that a player selected at random will be shorter than 5 feet 9 inches? So I'm going to use my highlighter. We're going to indicate where 5 feet 9 inches is, and that falls right here. So that's 2 standard deviations out from the mean. And we want to know the probability of being 5 foot 9 inches, or shorter. So anything that falls on this side. So we're going to add those percentages together. That's all we're doing here. We're adding 0.15% plus 2.35%. And our solution will be approximately 2.5%. So if I was to answer this as a complete sentence, I would say approximately 2.5% of the players will be shorter than 5 foot 9 inches. And that's what we're looking for an answer. So you're going to do something similar to all of these. For example, part B says, what is the probability that a player selected at random will be between 5'11" and 6'3"? So 5'11" is going to be here. We want everything up to 6'3". So the player is going to be in between those two heights, and you just add your percentages together in those columns I highlighted, which is 34 plus 34%, and that's equal to 68%. So if I was to answer this as a complete sentence, I would say approximately 68% of the players will be between the heights of 5'11" and 6'3". And for part C, it says, if there are 240 players in the league, about how many players are taller than 6'3". Okay, so this one's a little bit more difficult because first we need to figure out how many players, or what is the percentage of players that are taller than 6'3". If we come up to our chart, 6'3" falls here, and we want anything taller than that. So let's add those percentages together. We have 13.5% plus 2.35% plus 0.15%. And this is equal to approximately 16% of the players. Okay, so now that we're asked a specific question, if there are 240 players in the league, then we need to know how many of those 240 would be taller than 6'3". Well, 16% of that 240 is going to be taller. So we're going to multiply 240 times 0.16 because you have to multiply by the decimal of the percentage. So 16% is equal to 0.16. When we multiply this out, 16% of 240 is approximately 38 players. So this is a two-part problem. You absolutely have to do both parts. First, you find the percentage of the players using the normal distribution curve, and then you take the total number in the league and multiply it by that percentage. That gives you your exact answer. Number 2 says the average time it takes sophomores to complete a math test is normally distributed with a mean of 63.3 minutes and a standard deviation of 12.3 minutes. That means our mean of 63.3 falls right here in the center of our curve. And every time we move up or down, we are adding our standard deviation of 12.3. So we're adding 12.3 or we're subtracting 12.3 for each of our standard deviations. Okay, I just wrote this out for you so that we could quickly go right into the problems. I think that the curve is the same every time, so you should be able to follow along with what I'm talking about when we jump right to this. So let's go through our 3 parts and answer these completely. Part A says, about what percent of sophomores takes more than 75.6 minutes to complete the test? So here's 75.6. We want everything larger than that. That means we are going to add 13.5% plus 2.35% plus 0.15%. And that's approximately 16% of the students will take more than 75.6 minutes to complete this test. Part B says what percent of sophomores take between 51 and 63.3 minutes to complete the test. So 51 is here and 63.3 is our mean. So we're looking at just one of our columns. We're looking at one standard deviation. We can instantly say that's 34%. And our last part says about what percent of the sophomores takes less than 63.3 minutes to complete the test. So 63.3 is our mean, and that would be everything less than that we're looking at. So what percent takes less than 63.3? As you can assume, obviously our curve adds up to 100%, but to be accurate, you should add your percentages. So 0.15 plus 2.35 plus 13.5 plus 34% is equal to 50% of the sophomores take less than 63.3 minutes to complete the test. Okay, if I was to tell you that there were 24 students in the class and 50% of them take less than that, if I was to ask you what that is, then you would tell me obviously 24 times 50% is 12 students. That's not the question here, but there could be questions like that. Okay, please complete the on your own section by yourself. Press pause on your video. You can come back here and you'll see the answers, but you should be trying to complete this on your own. Sketch out your normal distribution curve. Remember, the percentages never change, only those standard deviations change. Let me know if you have any questions.